then we can share the recording and also upload them on YouTube. The last workshop was not uploaded, unfortunately, but we will do in the next weeks and share with you. Okay, so welcome to everybody. Thanks for joining this third workshop on the Geopackage of EJP soil. In the workshop today, we will be first answering on the topic of no, can you go to the previous, sorry, Stefania. We will first answer to what arose the last meeting that is about the texture, that there was some discussion on the topic, so we will answer to this, so to clarify any doubt. And then we will go through the main content of this workshop, which is about example of using the Geopackage to DBMS-R on Python, and also uploading data sets through Hale Studio. And then with this, I give the floor to Stefania, who will be doing the main of this workshop.
Good morning, everybody. So a brief outline of what we will see today. As just said by Maria, we will start with the insights from the previous workshop and the particle size fraction of the soil profile element will be the first topic. And then we will see example of use of the INSPIRE-SOIL Geopackage in different environments. Then we will have a coffee break, and we will then start again with example of data loading from other databases or data in other formats and structures using Hale Studio. We will have some basic of Hale Studio for those of you who do not know. And then we will have a live demo and upload data in the INSPIRE-SOIL Geopackage. Simple sample data from Lucas will be used. And then we will end with an introduction to the next workshop that will be about soil code list and vocabularies. So let's start with the insights from the previous workshop topics. The first one is related to soil profile element and particle size fraction, as I've already said. So INSPIRE profile element. A profile element is a part of a soil profile. That is, a soil profile is described by one to many profile element, and each profile element must be part of a soil profile. In INSPIRE, profile element is the general term to indicate both horizons and the layers. In the UML, it is an abstract class for grouping layers and horizon and/or horizon for functional aim, for operational aims. Let's have a closer look at the particle size fraction. The particle size fraction is an attribute of the profile element class. It is meant to indicate how much of the soil material is composed of soil particles of a specified size range. It is of a complex data type, meaning that it is not just a character string. In INSPIRE, it is a complex data type composed of several sub-attributes. The first one you can see showed on the right side of the slide. The first sub-element is the fraction content, which is a number, and indicates the percentage of the defined fraction. The second sub-element is fraction particle size range, which is in turn a complex data type. So it is made of upper value, lower value, and unit of measure. So, for example, content of the fraction particle size range sub-element would be upper limit 63, lower limit 20, and unit of measure micrometer. In INSPIRE, the unit of measure for the particle size fraction type is micrometer. And sum of the percentages of all fractions should be 100%. So this is particle size fraction in INSPIRE. Let's now see how this has been implemented in the INSPIRE-SOIL Geopackage. So we have the profile element, and we have the particle size fraction type. This is a separate table in the Geopackage, because we need to handle the multiplicity, because to the profile element, to a single profile element, the horizon or the layer, belong different fraction types. Then we have, but clearly this table is connected to the profile element through the ID of the profile element. There is a foreign key to the profile element table. Regarding the other attributes, we have the fraction content, so the percentage, then the particle size minimum and maximum, that are the upper and the lower limit. So it is the same as INSPIRE. And the default unit of measure is micrometer. So we have absolutely the same structure as INSPIRE, same information that is encoded in this particle size fraction type. Then, to facilitate reading and editing of a particle size fraction details in QGIS, styles have been created by CREA colleagues. What are the QGIS styles? They are custom designed forms that assist user in consulting and entering data in a more human readable format. QGIS style change the way data is presented to the user, but the data and the data structure remain unchanged. Now we have a short video, very fast, going very fast, in which we will see which was the previous QGIS style that was associated to the particle size fraction, and that included a categorization that caused some observation from your side. And then we will see how this particle size fraction style has been updated in the INSPIRE-SOIL Geopackage. So here we go with the video. So the previous one had this expression with the categorization regarding the particle size. Now this has been changed, and the expression now for the fraction content just shows which is the fraction content, so 18.5%, 30%, and so on. And next to it, you will see which is the particle size upper and the lower limit expressed in micrometers. With this, I hope the particle size fraction issues and questions have been clarified. If not, please write questions in the chat, and we will come back to you in the question and answer time. Now I want to show you an example of use of the INSPIRE-SOIL Geopackage. This was meant to be presented in the previous workshop, but there was no time to illustrate them all, so I will show today. The Geopackage format is well supported by mainstream software and tools. Geopackage, we said, it is a database container and can be handled as any other database. And today we will see how it is possible to calculate average soil depth by WRB reference soil group for the data which is contained in the INSPIRE-SOIL Geopackage, which is shared in the EJP soil GitHub. We will do this using 3 different tools. So we will do the same thing in three different environments. First, in the Beaver, which is a database management system, then in R, and then in Python. So let's go. There are three very small videos. So let's start with the DBMS. We wrote down a query. Then we opened the Beaver and connected the INSPIRE-SOIL Geopackage. And then we opened the console, wrote down the query, and ran it. And as you see in the lower part of the slide, the results are shown. So the average maximum depth by WRB reference soil group. Clearly, these results can be exported, for example, in Excel or CSV from the Beaver. And same goes with other DBMS like SQLite, DBMS, whatever you want, which is the one you use in your daily operation. Then we go with R. In the R environment, we need to load a library, so SQLite for R, and the Geopackage library, and then we have to connect clearly the INSPIRE-SOIL Geopackage. Then we open it. Write down our code and run it. And now you can see in the upper part of the slide, of the video, that we have our results, average maximum depth by WRB reference soil group. Also, these can be exported clearly. Then, let's see in Python. You also here, you have to import SQLite 3 library and connect clearly the Geopackage. And here we go with the program. Okay, we write our Python script and run it. And in this case, we export it in CSV format. And we have our average maximum depth by WRB reference soil group. Okay, there is some work in progress that we did not have time to show during the previous workshop. So what is currently available in the EJP soil repository on GitHub is the SQL statements, or the file SQL that allows you to create the geopackage. Also, the geopackage template is available, so already done, but there is also the SQL file. It is available also, the SQL file, to create the PostGIS corresponding, that has the same structure as the SQL, the geopackage. So that one can use the geopackage, which is a file which is very light, to share data or just to have the file simply shared, and then can store more data in the server, in the PostGIS server for daily operation. So with data coming from different countries, for example, or different regions in a country, or whatever. To these ones, so to both the geopackage and the PostGIS, you can associate styles in QGIS if you use QGIS. And these are available as well in the EJP soil GitHub repository. So what is work in progress? The work in progress is related to the creation of the Hale Studio project that uploads in PostGIS the data that is encoded in the geopackage format. This will be quite a simple Hale project because the structures of the geopackage and the PostGIS databases are the same. So we have the same tables, the same columns in the tables. And also, if you open, for example, your SQL file, the SQL file that are shared, you see that they are quite common. 95% they have the same code, the same statement. And I guess this is all as regards the previous topics. So it's time for question and answer, if you have any, regarding the particle size fraction, regarding how to use the soil geopackage in other environment. And this is the right time to ask. Otherwise, we have a very short break because then we will change topic. We will talk about Hale Studio. And so.
And how to import
yes, how to import datasets. So we will change topic. If you have questions, it's now it's the time. Otherwise, only 5 minutes break, and really 5, and then we'll start with Hale.
I want just to report on our conversation we had with the Portuguese colleagues before the starting. They were asking to us if the data set that were, I mean, the metadata that we have collected about data sets that are available in EJP-SOIL program, if these data sets will be imported in this geopackage structure actually during the time of the EJP-SOIL program, which is ending at the end of January next year. And my answer was no, in the sense that we are now, we have produced the tool, we are now sharing how to use the tool, but then the activity depends on the countries and that want to use this tool. And also we are now doing this workshop to give an insight of how it is structured, the tool, how to do the things, but I'm fully aware that to put in practice this uploading of data sets from the countries, there would be maybe more help, more activity to be done together with informaticians in every countries to actually use the tool. So these are meant to be a first insight on how it functions, what is behind, and so on. But it do not imply that all the things are done in this for workshop of. I mean, 2 hours each one is impossible to tackle all the issues. Yes, just to answer what was asked during before the starting of this meeting.
Thank you.
I cannot currently see the chat, but
I don't see any answer coming from the chat, so I suppose that things
everything is clear.
Yeah, I think so.
So let's pause for really only 5 minutes. So we will connect again 11:30. So I just pause registration.
Okay.
record. Okay, so let's dive into the example of data loading. So in the previous workshop, it was showed how to input data into the Geopackage using QGIS, so one record at a time. In this case, we will see how it is possible to perform bulk data loading, so data coming from other databases or data which is in other formats and structures. And we will use to do this Hale Studio. It will be a simple example using sample data from Lucas. Specifically, the exercise will consist in importing sample soil plots. We will have only 18 records, but just for time constraints related to the demo. But it is possible to rerun this project that will be shared with you in the EJP soil GitHub repository with all the complete source, so with also millions of records. It's just a matter of reloading the data. So we will import these sample soil plots and associated organic carbon observation from Lucas into the INSPIRE-SOIL Geopackage using Hale Studio. But before doing this, and with the aim to make what we'll be demonstrating easier to get, I would like to have a brief recap from workshop 1 on how to provide measurement in INSPIRE-SOIL. Physiochemical measurements on soil objects are modeled through O&M observations. So physiochemical measurements here, I mean both physical, like the textural class, the percentage of clay, silt, and sand, and chemicals like the organic carbon, the pH. The soil objects are those we have seen in the previous workshop, so the sites, soil plots, soil profile elements, so that is layers on horizons, and the O&M as the structure that you see here in the picture, and that I will illustrate in this slide. So we will start from having the soil plot, and we will then create the soil profiles and the layers for this, always using the input from Lucas. We have the observations. So the observation will be linked to the layer through the feature of interest association. So the observation generally in the O&M is associated to its feature of interest. That can be a plot, can be a soil profile. In this case, however, will be a soil profile element, specifically a layer. Then we have the observed property. So the observation is related to its observed property, so to what is observed. In this case, is the organic carbon content, and the unit of measure is a gram per kilogram. The observation is as well linked to the process that is used to carry out the observation. In this case, is ISO 10695, 1995, and clearly the observation is linked to the result, for example, 16.2. Let's have a look now at the DB schema of the INSPIRE-SOIL Geopackage, just to lets you see which will be the tables addressed in our exercise using Hale. You can see them circled or squared in red. So the soil plot, the soil profile, the related profile elements, the unit of the observable property and the unit of measure, and clearly the observation. There is another table which is really essential, which is the data stream table, which is meant to link the observation to the related feature of interest that in this case is the profile element. So in this case, the data stream will link the observation to the profile element and to the related observable properties. A brief introduction to Hale Studio for those of you who never used or never heard of. It is an ETL tool, so extract, transform, load tool for data transformation. It's open source, it's free, Hale Studio version is free, and it is designed for transformation of large and complex data sets. It is really used, it's one of the most used tools to create inspired data sets, but it is really useful for database to database migration and also integration of data coming from multiple sources. It supports schema validation. We will see when I open the Hale tool workbench. And as a user-friendly UI for interactive mapping, and as command line interface in case you want to schedule execution of your Hale Studio project. A typical workflow in Hale Studio is the one you see here in the slide. So you start with importing source and target schema. Don't worry if it's not clear now, because we will see all these steps one by one in practice. Then you import data from your source. This operation is indeed optional, but I recommend to do this because if you import source data, you enable a live validation from Hale, meaning that your mapping steps are validated as soon as you do them. So if you are doing something wrong, for example, trying to store a character string in an integer, just to make a simple example, an error is thrown immediately. So this is really useful. Then you identify the relationships between your source and target data types. So which property goes mapped into which property of the target type, and add identified relationships to the alignment panel in Hale. And then you export data transformed by Hale in the desired format and structure. Can be Geopackage, GML, database tables, could be GeoJSON, can be really different formats for any needs. Just a recommendation that is related to the identification of relationships between source and target types. In order to support the creation of the Hale project, I recommend to create mapping tables before starting to create the project. Why? Because it is important that lets you identify clearly which are the relationships between the properties, the elements of the source and the target. The mapping table is an Excel file. You see it in the slide on the right, where you write down which is the source type. If there are any source type conditions, you will see we will have one. in the Hale project, which are the source properties and which is the target type, the target properties. And the relation between the source properties and the target property. If you have to just rename and use as is the property in the source, or maybe if you have to do any type of conversion through a formatted string, or you have to transform a character string to integer or something similar. So the mapping table, as I said, is useful for visualize and identify the relationship between the properties of a source and target, but also to think about rules for the creation of specific properties, identify possible information gaps, and possible pre-processing activities, because there might be the need, and in this case, there is the need for some pre-processing activities. I spoke about rules for the creation of some properties, and here is a rule that we will apply for the creation of an attribute of the INSPIRE-SOIL Geopackage, that is the UID key. In the INSPIRE-SOIL Geopackage, the UID key column is used as foreign key. So it is essential to link tables to one another. Since we are creating and we are associating, we are creating soil plots, we are creating soil profiles, soil profile elements, and in the source data we use, that is in Lucas, there are no ID key information that we can reuse, so we will build them. We need a rule to create these keys and to reference from one table to another, so that the relationship between the soil profile and the profile element works through the foreign key. So it was decided in this case to create GUID keys in Hale using an information that is in the Lucas shape file, that is the plot identifier. So we will take the plot identifier, so the point ID column from Lucas, and we'll prefix it with the feature name. For example, if the point ID is 4,000,060,95, blah, blah, we will create a soil plot for this source plot, which has a guide key that is a soil plot underscore then the number of the plot, and the related soil profile will be soil that is related to the soil plot will have a guide key soil profile underscore then the point ID number. Hopefully this is clear, but it will become clearer when I will use this in Hale. And we also needed to do some pre-processing activities. Why? This because we are adding new soil plots to the INSPIRE-SOIL Geopackage that already contains Sicily plots, and that already contains the table with the observed properties and the related processes and units of measure. So since we are adding observations related to the plots and observation for organic carbon content, we need to know to link the observation to the observed property in the observed property tables. We need to know which is the foreign key, so which is the famous ID key that I was talking about before. And we needed to copy it and you will see how we will use this information in Hale. And same goes for the process. In this case, the process is the determination of total or organic carbon and the total nitrogen with elementary analyzer that is in the ISO 10695. So we took this guide key, we copied in our mapping table. You will see that the mapping table will be my companion when creating the Hale project. Last slide before we dive into the demo. It is important to understand that there is a data loading order. Why? Because to maintain data integrity and for content validation purposes, the INSPIRE-SOIL Geopackage contains triggers. Triggers are stored procedures that are automatically executed in response to certain events, such as insert new record, update record, or delete operations on a particular table or view. So triggers and foreign key constraints in the INSPIRE-SOIL Geopackage require data to be loaded in a specific order. For example, we cannot insert soil profile information if there is no soil plot information related to the soil profile. This is because the soil profile will try to link to the foreign key of the soil plot. Same goes for the profile element. We cannot insert the profile element of a soil profile if the soil profile itself has not been inserted. Same goes for the observation and so on. So we will follow a data loading order. So I will now stop here and we'll start with Hale. So this is Hale Studio. This is the workbench. It is quite intuitive. On the left, or at least I use it in my daily work. So for me, it's intuitive. I will try to make it this simple also for you. So we will have to load the source data, or the panel is the one on the left. Then we will load the target on the middle panel, and we will specify mapping between the source and the target in the last panel, so the alignment tab. So let's start. In this case, we will have to import our shapefile from Lucas. We can do this or either by clicking on File, Import, and then Source Schema and Target Schema and so on. Or we can do also directly from here. So we can import Source Schema and Target Schema. So Source Schema, in this case, I want to the input. We will use a shape of the soil plot from Lucas. So in this case, I am importing the shape. You can see in the lower part of the workbench that there is a report list on the right, the report list panel. And here you can see the outcome of the operation you just performed. So you can see that we have imported a shapefile and that this import has gone well because you see the green flag here. We will now import the source data for this shapefile. Okay. Also, in this case, if you look at the report list, you can understand that also loading of the data has gone well because there is a green flag. Now we import another source schema, that is the observation. So we want to have the observation. In this case, the source format is a CSV. Okay, Hale asks for confirmation that the structure he understands, it understands connecting to the CSV is correct. Yes, it is. And we click on finish. And then we import the source data for the CSV. So again, we click on the CSV. We have to choose, since we have now two source schemas, Hale is asking, what are you loading that data for? So in this case, it's not the plot, it's soil data, it's observation. Okay, so now we have imported our source. I just want to show you another characteristic of Hale, another feature. There is possibility to open your data in the map to have a check that the data is uploaded correctly and the CRS is understood correctly. In this case, it is because we are in Sicily, and you can see that the points have been correctly placed on Sicily. So let's go back to the default. So I can click here to go back to the default perspective, or I can open the perspective and select default. It's the same. Okay, we are back in our workbench. So now I am importing the target schema, which is the soil geopackage. So as usual, I can do from here, or I can do file import target schema. It's the same. So I am selecting my INSPIRE-SOIL Geopackage. Then I click finish. Hale confirming that geopackage import was okay. And you can see here the structure of our geopackage, so all the tables. If you open the table, you can see what the attributes, so for example, the soil plot, which are the columns of the soil plot. Now we are ready to start our mapping, that is to associate the source properties to the target properties. Now I am opening the mapping tables we created together with the CREA colleagues, in which it is specified which are the action and the mappings I must perform in Hale. For example, the begin span life version will be today. The GUID key will be a formatted string, which has an import, a source property, which is the point ID. But in output, it will create a GUID key that is a soil plot underline point ID, and so on. So the source type, we have created the mapping table with all the needed source type and target type. So we created also, we have rows for the soil profile, for the profile element, for the data stream, and then for the observation. So let's start. First operation, so the first in the list to be mapped is the soil plot, because we cannot map the soil profile if we have not mapped a soil plot. The soil plot must be associated to the shapefile, so the one we will take from here. So I will select the shapefile from Lucas. I will select as a source, as a target, I will select the soil plot table. And then I will tell Hale that I want this shapefile to correspond to the soil plot table. So I will associate the function, associate a type function that is retype. Hale is now, if you look at the report list, you see that Hale is showing a small yellow triangle. This means that there is something that is missing, and clearly it is, because we have not yet mapped the properties. But Hale is already saying, if I click on the triangle, Hale is saying that there are warnings, that is, there are mandatory properties in the soil plot that have not yet been mapped. So now I am doing this clearly. In the mapping table, I can see that for the begin span life version, I have to use a function that is called formatted string. And I have already, in the table, we have already specified which will be the value of the begin lifespan version. In INSPIRE, the begin lifespan version indicates which is the date in which the specific records have been inserted in the data set, so in our INSPIRE-SOIL Geopackage. So we will create them today, and it will be today. So it is 2024, December 9. In INSPIRE, it is the data type is date time, so it also contains seconds, but in our case, we don't need seconds. Okay, now the next attribute to be mapped is the guide key. In this case, we said we have created a rule that is from point ID derive a guide key that is soil plot underscore point ID. So I take the guide key, I take the point ID attribute, and then I use a formatted string. So we said that I want to use soil plot underscore point ID. And I click finish. Going again to the report list, because you see how useful it is, this live validation of the mapping activities that Hale performs, because here you can see that the instance transformation is green, so meaning that our transformation was good, so the mapping was correct, and there is still the instance validation with the yellow triangle, because clearly we still need to map soil plot location and soil plot type, which are mandatory. One interesting thing is that Hale allows you to also see how the data is transformed. If we go on we can click on this table icon here, where is data, but clearly we can also open from the perspective and select data perspective. And we can have a look at what is the source data and which is the corresponding transformed data that is created by Hale. In this case, we will see, for example, that point ID is for 6, 10, 16, 50, and that we have created a guide key that is soil plot underscore, the same number, 46, 10, 16, 50. So for the second record here, that we see that the point ID is 45, blah, 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 and the Guedicchi created this soil plot 45 and so on. So we can also validate our mappings in this way. Excuse me. So let's go back to the default perspective and go back to our alignments. So after the Guedicchi, we will now map the INSPIRE local ID. This information is not present in the original source from Lucas. And we are now using a rule which we created. So this is not the official INSPIRE ID for the Lucas data. It's just what we are using for our demo purposes. And we will we will create the local ID from the point ID so that the soil plot will have the same identifier both in the Lucas data and in the INSPIRE ID local ID. So I will select now the INSPIRE ID local ID, will select the point ID and associate them through RNAME function. Okay. The INSPIRE ID is made up of 3 information. That is the local ID, namespace, and version. Also in this case, we have in our mapping table, which is the value we want to assign to it. No, not the official one, the one we assign it for our demo purposes. And since there is, it is a string we are assigning, there is no corresponding value to use in our source. I will use a function that is named assign. And I will pass here, which is the value. The version ID, also this we decided to assign value 1 because this is the first version of the object. Okay, let's go to Hale. Also in this case, we have the assign function and we add here 1. We have also to map the soil plot location, which is a geometry. In this case, it is a point geometry. In our shapefile, this is the column we have to use. And we associate through RNAME, meaning that it is, we are telling Hale that it has just to take the value as it is and put in the soil plot location. Now, the soil plot type, we are importing from the INSPIRE code list and select the value sample. So we go to Hale and we will import code list from INSPIRE registry. Okay, we will select the soil. The INSPIRE registry contains clearly for all the INSPIRE data teams. We select soil, which is here. And then we are taking the soil plot type. Here it is. Here we go. Now the code list is important in Hale. We can assign the value to the field with the assign operation. Next, we will select the code list. And then once we have selected the code list, we can select which is the value from the code list. In this case, the INSPIRE code list only contains 3 values. So borall, sample, and trial pit. In this case, is a sample. So let's check that everything is fine in the data perspective. In this case, you can see that we have associated also the soil plot location, the soil plot type. Here, I open it so it is visible. We have also made the correct assigned to INSPIRE local ID, namespace, and version. So let's go back to the default. I will check that I have not forgotten anything. So soil plot location, everything is fine. So mapping of the soil plot is finished. Now I have to import the soil plot into the Geopackage. So I will export our transformed data in the Geopackage file. That is the INSPIRE-SOIL Geopackage. Hale asks me if I want to do any transformation of the coordinate reference system. I do not want. So I click finish, and hopefully let's keep our fingers crossed that everything is fine. So Hale is now confirming that our soil plots from Lucas have been imported in the soil plot table. Now we have completed soil plot ingestion, so I will disable this transformation in Hale and will create a transformation for the soil profile. If we go back to our mapping table, here we, too much. Profile element, soil profile. So the soil profile corresponds to, we will take information to put in the soil profile from the CSV of soil data. And we will associate them through a retype. So I select soil profile, I select CSV, and then I create retype. And now we map the specific attributes like just we did with the plot. So the first one is also beginning lifespan. Today is always today, so we just paste the same information that we used for the plot. So beginning lifespan, formatted string. Then I guess it is the time to the guide key. So we use the point ID, in this case from the CSV, and we use a formatted string to create this. So if I can copy, but I can here. So the point ID is here. Formatted string. We can use, just to let you see that I can write down soil profile and then I click here on the point ID, okay? Next one is the INSPIRE ID local ID, always the soil profile point ID. So again, formatted string. Namespace is the same as well. and version ID is always 1. Now we have to map the is-derived attribute. If we go back to the mapping table, we can see that is-derived will be assigned the value false. What is this attribute? In workshop number 1, we showed and we specified that in the INSPIRE-SOIL Geopackage, we have an attribute. We use the same table, that is the profile element, to store information both of observed soil profile and derived soil profile. So to distinguish between them, we have added this attribute that is the is-derived attribute, which is false when it is not derived, and true clearly when it is derived. In this case, we assign false. So if we go back to Hale, we have assign. Hale already recognizes that it is a Boolean. So it proposes to choose false, but we can select true in case we need, but in this case, it is false. Another Boolean is original classification that specifies whether the classification used for the soil profile is the original one or another one. In this case, it's not the original one, so we assign false. Next. Then we have the local identifier. In this case, we decided to assign to the local identifier the plot ID. The point ID, okay, assign. Oops, sorry, the name. Okay, then the location. Also in this case is a formatted string. We are telling Hale that the location is the soil plot, identified by the soil plot _ point ID key. So the location, point ID. I have a formatted string. Just to mention this, in this case, it's not needed because I had already selected point ID as my source, but one can click on this and to have the full list of columns available from the source. In this case, it's point ID. So next. Then the valid from attributes. It is a formatted string built using an information available in the source, that is the year. You see it in Italian, anno, but it says year. And we will use the year and then add January as a month and 1st January as a date, because we do not have the full date. So we are just using the year. We do not have the full date in the source data, but INSPIRE requires a date, not just the year. So valid from, I select year from here, and then I use formatted string. I don't remember if I selected this. Okay. So I was selecting this and then adding paste. So Hale will take the year from the source, then build a date using the year, then 1st of January and 000 seconds. Okay. We can see here that instance validation is okay, and instance transformation as well. This in the report list, we can see this. So we are ready to export our soil profile information in the soil profile of our INSPIRE-SOIL Geopackage. So I am now exporting transformed data for the soil profile in the Geopackage. So I select again the Geopackage as my output. Then go. Let's hope everything is fine. Okay. The data has been imported in the Geopackage. Okay. So I will now disable this transformation. Oops. And map the soil profile element. So let's go. Echo. Here it is. Again, we will have to soil profile element. It's here. We associate to the CSV input source, and then we say retype. We open so that we can see each specific element. And we start again. The begin lifespan will be today. So we assign today. Oops. It's a formatted string in this case. The string. So the GUID key is this one. So profile element point ID. No, underscore ID, not point. So we will assign a formatted string. In this case, we take the point ID from here. Okay. The INSPIRE ID is the same, so formatted string with a point ID. Then goes for the namespace. I will assign one to the version. Then there is this is part of. This is must be filled in with the foreign key of the soil profile it belongs to, the profile element belongs to. So how do we specify this to Hale? We will fill in the is part of attribute with the soil profile underscore point ID, which is the foreign key related to the point ID. So it is a formatted string, the point ID formatted string. So we go in the is part of point ID, and I forgot to copy soil profile just to edit already. It can correct way. Okay, avoid the typos while writing. That's why I'm copying. Okay, so associate the formatted string. So we still miss another mandatory element. We are mapping only mandatory element because we have information related only to that. The profile element type. The profile element types, if we go to the mapping table, it's an assignment, and it must be true, meaning that it is a layer. We have specified this during the workshop number 1. So I will assign in this case. Then we are also mapping the famous profile element depth range, lower value, and upper value, so the range type. So we see that we assign 20 to the lower value and 0 to the upper value. So we assign here 20 to lower value. And 0 to the upper one. The depth range is from 0 to 20. If we check the report list, we now see that everything is green, meaning that all mandatory information has been mapped. And we can go with exporting transformed profile element into the soil geopackage. So export transformed data in the geopackage file, which is always the same. Next, finish. Okay, profile elements imported. I will disable now. Okay. Now we are almost done. There is the data stream to be filled in. As we said, it is important here because the data stream allows you to connect observations and related profile elements. Okay, so let's go. The data stream itself has GUID. It's here. So let's open the data stream. Then we assign the guide key with the point ID, formatted string. Now we have to associate information that is not present in the source data. That is the ID of the observed property and ID of the process. In this case, the observed property is, we will use the carbon content. the organic carbon. And we will use the values that I showed in the slide. So that is, we did some pre-processing. We opened the observed property table of the INSPIRE-SOIL Geopackage and took the ID of the observed property, as well as the ID of the process. So we noted this into the mapping table. So this is the ID of the carbon, organic carbon content. So we will assign this to the observed property. I copied it all, otherwise the trigger will complain. The ID of the observed property, assign. And we will assign this value to the process. Okay, we can read in the report list that we are ready. Everything is green. We are not missing any mandatory stuff. So we are ready to export this into the Geopackage. INSPIRE-SOIL. Ah, we forgot something. Okay, so let's see what happens. How do we understand what is gone wrong? We click on the export, we go to errors, we click on the error, and we see the details. It will be so sure. Okay, so the ID has not been taken correctly because you say that this is the trigger. Says that constraint failed, check single ID. Okay, let's see. Maybe I did not pass it correctly. Let's see. The right key is made of. It is a formatted string with a point ID from file data. Okay. Point ID. Okay, let's see. Okay. It should be okay. Then the ID of the observed property, we assign this value. Hopefully this is the correct one, ID of the observed property. Okay, and we are missing something that is the ID of the profile element. So I forgot to map the ID of the profile element. Now that I'm looking at it, clearly the data stream connects the observed property, the process, and the profile element. So that's why it complains, okay? In any case, I will check that also the ID process is mapped correctly, so that we assigned the correct stuff. So you can see also this is an opportunity to see how it is possible to edit the assigned stuff. So assign is this one. No, I think it is Okay, then the ID of the profile element. So I will take the point ID, the profile element, formatted string, and then say profile element. Point ID. Okay. So hopefully, oops, transform data, Geopackage file. Okay, now it is okay. So the data stream has been ingested, and I will now disable the transformation. And finally, the observation, the last one. The observation, here it is. If we go to our mapping table, we will see that we have to retype clearly the Lucas soil data CSV as input source. In this case, there is a context. Why? When I mapped this the first time, I received an error because one of the, for the 18 records, in the 18 records, one of them is null. So if I go here on the organic carbon, and if I say properties, the occurring values here are 17. So we need, since in an observation cannot have null value for the result, I need to specify to Hale that the null records must be excluded. So in the mapping table, it is written that OC, organic carbon, should not be null. So I will click on the source. I will say that I will add a condition context. And I'm saying, okay, I can select directly from here. OC here is not null. You can see that only 17 records are not null. So now I am mapping the observation table to the source, which has all valid organic carbon values. So the observation, it is a retype. In the mapping table. So I have to link the observation to the data stream. So I will use the grade key of the data stream. So I will rebuild this here. So ID of the data stream and the point ID. Sorry. The ID of the data stream I will create. I've created before. So the formatted string point ID. Okay. But also the observation as a query key. There is no information in the mapping table, but it is clearly point ID, the key. Mapped string. Then we have the phenomenon time. We only have the year, so it's the same as the previous one. So we take the year from the CSV and we then add the 1st of January as a symbolic date. Then we have the result time, which is the same. So the formatted string with the anno, we saw with the year. And then clearly we have to map the value. The value is contained in the here, in the column named OC in the CSV from Lucas. So it's just RNA. Okay, according to Hale, we are fine. Let's hope we do not violate any trigger. I did not forget anything. It seems that I considered everything. Let's see if this is true, if my assumption is true. Transformed data, geopackage file. Okay. Now we are done. So we have imported in the INSPIRE-SOIL Geopackage the observation from Lucas. So we are done with Hale, and we can maybe just, we have time for this very quickly. We can open our file in QGIS just to see that this has been imported. So should be here. Where is it? Workshop. No, it is here. Studio project. We have created in the output folder, so it is here. We can close Hale. Okay, let's say that we want to save this project archive. Okay, this is just to show you. We can save the Hale project as Hale project that is it saves also which is the path to the source, or and the output, the path to the source and the output files, so it remembers where it is. And if you move then the project, it throws an error. Or we can save as a Hale project archive, meaning that it creates an archive which contains the data you used. So if you move the project to another folder or to another system, you do not have errors. So we will create a project archive now, demo. Next. So I will save in the output as a demo. Okay. I will then close this and try to open in QGIS. Still writing this, it's OneDrive that is still updating, but let's hope that everything is good. Okay. Here are the soil plot. Let's disable this, so we concentrate on the soil plot. If we categorize this in the properties, okay, you can also, using the QGIS styles that are in the EJP soil repository, you can also apply this to your Geopackage if you want to apply the same stuff. We will avoid this now because we are already in a shortage of time. I forgot to say the soil plot type. Okay, then classify. Okay, we have the sample in blue and the trial pit in green. So if we, okay, hopefully you can see this. If we ask for information on the blue points, okay, you can see that it is coming from Lucas. So we have the soil plot, we have the related soil profile, we have the profile element, the data stream, and the observation. I hope you can see it. So in this case, the carbon content is 23.4. And with this, I will stop sharing. Do you have any questions related to this demo?
I would like just to just clarify that all this process that you have done to import this example data set is to be done in a lifetime. So it took a lot of time to match everything, but when you have done this for your data set, you do not need to do it again all the time. You will have the project saved, as was explained by Stefania and Sean. And then if you want, you have more data that you want to import, you will use the same project in Hale. So it is just to do this one time.
Yes, in the sense that clearly we mapped all observation related to organic carbon. I hope you can now see my screen again. Yes? Can you confirm you can see my screen?
Yes.
Okay, perfect. So we have illustrated how the organic carbon observation from Lucas source are associated with the related soil profile elements, that is, the related layers. If we want to associate, for example, pH observation that were present in the CSV by using Hale out-of-the-box functions, we would need to rerun the project using the pH field instead of the OC while mapping the observation table, so the last one. And so again, for all the properties, so I don't remember which are the other ones, the clay, the silt, I remember that they were there. However, it is possible to associate the observation for all the observed properties with the related layers in a single shot. So in the Lucas CSV, there were, for the same layers, observation related to organic carbon, to pH, to clay, to silt content, and so on. We can associate all of them in a single shot, so with only one project, instead of rerunning several times the same project, just changing the property. But we would need to use advanced Hale options. So there is no function out of the box that easily allow to transform data just like I've shown during the demo. You need to write some Groovy script. You need an informatic, a computer scientist to do this, or you must know how to use a Groovy script. I just provide here a very simple example for two properties. But clearly, I am just showing to let you understand how this can be done. But you need to be skilled in Hale and in writing a Groovy script. Otherwise, you cannot use this. In this case, I am creating an array of arrays. So I am collecting the data stream property. So I create a record for the organic carbon, then I create a record for the pH. I can add another record for the coarse, for the sand, for the silt, and so on. And then assign this through the Groovy script to the target, which is the observation. So this is not easy, and so it cannot be explained during a workshop of 2 hours during a demo. So I just want to show that this is possible. And now I'm really stopping my intervention and leave the floor to Maria.
So in regard to the next workshop, we have demonstrated up to now some demos of what can be done in relation to the geopackage soil that we have produced also importing the data that we have for Sicily, but not all the properties were implemented up to now. We have implemented what was mandatory, for example, the particle size fraction. We have implemented for pH and organic carbon, but we have more properties that, for example, also for Sicily, that could be implemented. And now in the INSPIRE Geopackage soil, with the properties for Sicily, we have only pH and organic carbon. So in the next workshop that will be in January, we will speak of something that is very, very complex as a subject, which is the use of vocabularies, the use of lists of properties that are available officially online and that could be integrated in the Geopackage, so to extend to other properties, because we know that we are just at the beginning. We have implemented only few ones, but we have a lot more properties in soil that need to be implemented. And so this will be presented in the next workshop in January, in which we will explain how, first of all, which is the concept of vocabularies, where are already available vocabularies. For example, for soil, there is the glosses that I suppose that you have already heard about, that has done a very good and enormous work in collecting a lot of soil properties for soil. And so we will teach about this topic of how to extend our geopackage with more properties that are already available, and also how to do this, I mean, in an official way, because, for example, we have started this for Italy. So several of the codes that we use officially in our data set has been imported in an official registry for Italy that is maintained by official institutions in Italy. And so this should be done by all the countries, so that all the list of vocabularies are there available then to be used in the Geopackage. Since I didn't prepare any slide for this, I hope that I was complete in the introduction. Please help me, Giovanni or Stefania, if I missed something about the following workshop.
You were perfect.
Okay. Yes, Andrea is here next to me. But I think that he is okay with what I said. Yeah.
Okay. If no questions come, we can stop the recordings and we can close the workshop with 5 minutes in advance.
Yes, that's incredible.